Hello there. In this short video we're going to be looking at percentage change as grade B in difficulty, and it's part of the Aqua Unit 1H. Let's look at the sort of questions we have to solve. Ben invests £140, 4% at a rate of 4% per annum, which means per year, compound interest. And we're going to have to find out how much he has after 2 years and after 5 years. Let me just get my calculator. We'll need that for these problems. Well, I'll get my calculator in a moment. Let's look how we start. Now, the key is identifying this phrase here, compound interest. It means interest is added on at the end of a year, and then in the next year some interest is added on the original amount, which will of course have gained some other interest, and so on. So the interest keeps adding, going into the pot, if you will, and then interest is gained on that. So it accumulates, it grows. Now, enough of that drivel. How do we solve the questions? Well, we start with the original amount, the investment. Now we ask ourselves, 4% increase. So the original was 100% plus 4% means we'll have 104% of the original. Now as a decimal, that's 1.04. So to find out how much I have at the end of 1 year, I multiply 140 by 1.04. But as it's compound, I have to raise that 1.04, the multiplier, by the number of years it's invested for. So it's to the power 2. And then I get my calculator out. Let's see if you can see this. And I let it do the work. So I type in oops, beg your pardon, so you can have that one button. Oh, fiddly dee indeed. Actually, I'll tell you what, let's go full screen. No, maybe not. You know, this is unpolished, isn't it? Here we go. 140 times 1.04 to the power 2. And there we have the sum. It's £151.424. So that's part A answered. Well, actually, what would happen with this bit here? You don't get 0.4 of a penny. So the bank would probably round that down to £151.42. Now, what about part B for 5 years? So we start off as before. There's our principal, the amount invested, times our multiplier. It's 4%, so 104%, which is a decimal, is 1.04. And this time I raise it to the power 5. So let's get my calculator out. Let's clear what we had before. I type in 140 times 1.04 to the power 5. Press execute, and there we have £170.33 to 2 decimal places. £170.33. It's £170.33. My memory is so sieve-like. Yes, it was. And there we have it. That's how you work out compound interest problems. But let's look at a more involved one. Now, Ben again. He wants to make £1,000 by investing some money. How long will it take an investment of £400 at 17% to reach £1,000? So let's look, how will we start that? Well, there's our original amount, the investment. In this part of the question, it's £400. Now let's think to ourselves, 100% invested at 17% would give us at the end of each year 117% of the amount at the beginning of the year, which is the decimal is 1.17. So I do 400 times 1.17, but I don't know what power. Now what's the simplest way of doing it? Well, we just pick some numbers. Let's have a look. £400, that's about half of 1,000, is it? So let's go for 5 years. See what happens when we put 5 years as the length of time. Whoops, let's just clear this. So 400 times 1.17 to the power 5. That gives us £876, 97 odd pence. Not enough. So let's try again. Instead of 5 years, let's try 7. So we do 400 times 1.17 to the power 7. There it is, it exceeded it. Now, would 6 years have been enough? Let's just try 6 years. £400 times 1.17 to the power 6. And it was just over. So the answer is 6 years. in which case he'd get over £1,000. Was it 1,026? What about if he invested more? £800. Well, we've got our multiplier, 1.17, but we don't know what power to raise it to. Now, if 6 years enabled us to get to exceed £1,000, with £800, it's going to be less time, isn't it? It's probably going to be about half as much. So let's go for 3 as our first length of time. So we do 800 times 1.17 to the power 3. Oh, that exceeded it by quite a large amount. So let's try 2. Maybe 2 years would have been enough. So we do £800 times 1.17 to the power 2, and there it is. Now I can't be sure that he couldn't have achieved that £1,000 in a year. So let's just try what £800. Let's just clear. £800 times 1.17 is 9. It's 8,000. Silly me. 936 pounds. So after a year he won't have over 1,000, but after 2 years he will. So the answer is 2 years, and the reason is because £800 times 1.17 to the power 2 is greater than £1,000. So that's compound interest, and they're quite involved questions. These are probably bordering grade A. So look at the last type percentage questions that come up in Unit 1H. Working backwards. Here we go, look. John's wages go up by 5%, £420 per week. How much was he earning before the rise? So what we've got to do is, we'll let X equal before the rise. Now, I'm going to use a bit of algebra here. What's happening? What is wages go up by 5%? So if we think 100%, always start with 100% in your head or on paper, plus 5% equals 105%. What's that as a decimal? 1.05. So X times, that was his original amount, 1.05 equals 420. Or I always like to have the number in front of the variable. 1.05 X equals 420. As you know, if you've seen my videos on algebra, this bit is simplicity itself. X, the original amount, equals 420 over 1.05. Out comes the calculator. 420 divided by 1.05 equals, and there we have it, £400. Now, if you don't like a bit of algebra, then you're probably not going to do very well in the higher paper, but you could just simply do this. You just take the amount after the rise, and normally you multiply by the multiplier, but because we're working backwards in time, finding out what happened before, you divide. You might want to just remember that as a rule. Right, look at one more of these. A laptop is reduced by 40% in the sale and now costs £235, 40 pence. What was the original price? I like algebra, so we'll let X be the original price. Original means before any changes. So X times, well, what was the multiplier? Well, originally it was 100% of it, and then we took away 14% to give 86%, which as a decimal is 0.86. So X times 0.86 equals our new amount, 235.40. So we like the coefficient in front of X. So 0.86x equals 235.40, and then take the coefficient and put it underneath the number on the other side of the equation. In other words, divide by it. So it's clear what we had before. So what have we got? We've got 235.40, £235. Whoa, what's happened there? Sorry guys, bear with me. £235.40 divided by, I'm going to use the ABC because it appears as a fraction in my working. Same thing occurs. You divide by 0.86, and what do we get? £273.72. Got the answer, £273.72. Let's just double check. Look, it's gone down. So therefore, my answer should be bigger than £235.40, which it is. Okay, thank you for listening. Sorry once more about the lack of polish of these videos. One day when I have more time and I'm not harassed by having to mark lots of books and keep a department running, I'll get these off pat. Anyway, I hope this helps before the exam.